Alright, number 7, we have f of x defined as following. So we got another piecewise function, 3 pieces here. And we want to find f of negative 3, b of 0, and f of 2. Alright, so let me write those. And what you need to remember is what this notation means. So f of negative 3 means we're going to be replacing x with the negative 3. Now the question is, which of these functions do you use? Okay, because there's 3 of them. You got this one, and this one. You certainly don't use all 3. So again, you have to look at the restrictions or the domain that defines each function. And negative 3 would fall in the x values that are less than 0. So that means we have to use x squared. So in here, I'm going to be using the x squared equation. So when I replace x with the negative 3, that means I'm doing negative 3 squared, and that gives us a positive 9. Okay, so here is just looking at the notation and plugging it into the right piece of the function. So we get a positive 9. Alright, now we want to know f of 0. So 0, when x is 0, we use the middle function because it says x equals 0. So we will plug a 0 for x. Well, if you look over here, there's no x to plug in. They just give us this number 0. So when x is 0, they're just telling us that the y value is also 0. We don't have to solve anything. There's nothing to plug in. We just get 0. So it's a constant function there. So we're going to plug in a 0. And then, part 3, C, we want to know f of 2. Okay, so when x is 2, we would use the third equation because these are all x values greater than 0. So if I plug a 2 into this expression, we have 2x plus 2. So we're going to do 2, replace x with a 2, plus 2. This gives us 4 plus 2, which is 6. So we get a 6 for part 3. Okay, so number 8, we have this function defined. We want to know the domain of the function. Okay, so let's talk about this. So 3x, and just from past experience, you can also graph that. 3x would just be like a linear equation. Actually go through the origin. So 3x will be a line like this. Okay, any linear equation, the domain is all real. So we would get a domain from negative infinity to positive infinity. Okay, the whole number line, it would go across this whole x-axis. However, they say x cannot be 0. So this point right here, when x is 0, this point would be removed. So you'd have this piece here and this piece here. So 0 is gone. That's on this first equation. Now, this equation says we're going to use 4 if x equals 0. So they just add a point. So say 1, 2, 3, 4. So we have a point 0 here. So if you combine these two graphs, this point, this line, is missing the point 0. However, the point 0, when x is 0 here, because the number line goes, negative values, and then positive values here, and zeros in the middle. So when x is 0 here, we do actually get a point on this overall whole graph. So if you combine these two equations, this line, which is missing 0, and this dot, which is like they just took this point 0 and shifted it up, you do still span the whole number line. So your domain is still all real numbers because you will get every value of x. So domain is going to be negative infinity to positive infinity. So that's the first part. now we want to locate any intercepts. Okay, so if you look at this expression, when we try to find intercepts, we got to remember x is 0 or y is 0. So we got two parts. We have 3x, and we have x cannot be 0. So the only thing we can try to find here is a y-intercept, or not the y-intercept, the x-intercept, because we cannot let y be 0. And these both, you can look at them as y equals part, and then we have another one, y equals 4. Okay, so in this expression, x cannot be 0, so there's no y-intercept. Maybe there's an x-intercept. Let's say x equals 0. If I plug x equals 0, nope, we can't do x equals 0, I'm sorry. Y equals 0, keep mixing myself up. X-intercept, y equals 0. So we have 0 equals 3x, divide by 3, and we get 0 equals x. Okay, so we can't have x equals 0, so there's no x or y intercept for this part. However, if I go here, we just get y equals 4. There's no x to plug in, that is my y-intercept. Y-intercept is x equals 0, nothing to plug in but y equals 4. We get that because they tell us that x equals 0, y is 4. So that is your y-intercept. We can't plug in x equals 0, so that's all we can get. So we get one intercept. That would be 0, 4. That's on the second part, and we can't plug 0 into the first part. Okay, now we want to choose the correct graph of this function. So I did show you a linear equation, and this is, let me make this full screen so you can get a better view. So a linear equation with a dotted 4. So this one and this one match. But you have to find the slope. So the slope is 3. So if I started here, I'll go up 3. Let me make this bigger so we can see. I will go up 3 from 0. So 1, 2, 3, and right 1. Okay, that point right there does not land on this line, so that doesn't match. Let's look at this one. These are the only two that have that 0.4 that's listed in the right position. So we go up 3, 1, 2, 3, right 1. That matches. And if you follow that pattern, this graph here would match. Be the best. So D. And then part D, based on the range, or based on the graph, find the range. I'm going to select the choice that best fills in the box. Okay, so when we look at this graph, this line goes all the way down, so all of the negative y values. When y is 0, we have a hole, so we don't get y equals 0, and then it continues going up. And even though there's a dot off to the side, this is when y is 4, we still have a point on the line where y is 4, so we don't have to list it twice, it doesn't matter. But the only point we don't get going up and down on the y-axis is 0. There's nothing along this line. So we have a split range. Your range will go from negative infinity to 0, and then union 0 to positive infinity, going from bottom to top. So that's what our range would look like from our graph. So there's different options that you can choose. This first one just says if you had to list, like if it was a scatter plot that was just dots, you would list them. Since it's a number line, we can't list every number to infinity. So we're going to use, we can't use B actually. B would be if we had two parts. So let's say if my graph did something like this. I had a part of my graph that just came up so far and stopped, and then I had maybe like another piece up here. So that would stop at like 1, and then we have another point, let's call it 2. So So you would do a range, and then you would do a point. We don't have anything like that. Or in our case, this 4 is also included in the long part, so we don't have to do it in 2 separate pieces. So option 3 is what we want, and we're going to list it just like this. So negative infinity to 0 union